Energy is the lifeblood of civilization. We convert it from one form to another, powering our homes, industries, and transportation. Heat, a fundamental form of energy, is particularly important. It drives many of our power generation processes. Converting heat to electricity is a cornerstone of modern society. This conversion process relies on a fundamental principle. Heat can be used to create motion. This motion, in turn, can generate electricity. Understanding this principle unlocks the secrets of power plants and the technologies that power our world. Where does this heat come from? The answer lies in the diverse and abundant energy sources our planet has to offer. Earth offers a diverse array of heat sources, each with its own advantages and challenges. From the burning of fossil fuels to the harnessing of the sun's rays, the variety is immense. Fossil fuels like coal, oil, and natural gas have long been our primary energy source. These fuels are formed from the remains of ancient plants and animals, compressed and heated over millions of years. However, their use comes at a cost, releasing greenhouse gases that contribute to climate change. The burning of these fuels releases carbon dioxide and other pollutants into the atmosphere, leading to global warming and health issues. Nuclear fission, the splitting of atoms, provides a carbon-free alternative. This process releases a tremendous amount of energy, which can be used to generate electricity without emitting greenhouse gases. However, it also generates radioactive waste that requires careful management. The waste remains hazardous for thousands of years, posing a significant challenge for storage and disposal. Renewable sources like solar thermal, geothermal, and nuclear fusion offer the promise of clean and sustainable energy. Solar thermal plants capture the sun's heat, geothermal power stations tap into the Earth's internal heat, and nuclear fusion, still in experimental stages, aims to replicate the sun's energy production on Earth. Additionally, wind, hydroelectric, and biomass energy contribute to the renewable energy mix. Wind turbines harness the power of the wind, hydroelectric dams utilize flowing water, and biomass energy is derived from organic materials. Together, these diverse energy sources can work in harmony to create a sustainable and clean energy future. By balancing the strengths and weaknesses of each source, we can reduce our reliance on fossil fuels and mitigate the impacts of climate change. At the heart of many power plants lies the mighty steam turbine. This ingenious device harnesses the power of steam to generate electricity. The process begins with heating water to create high-pressure steam. This steam is then directed through the turbine, causing its blades to spin rapidly. This rotational energy is transferred to a generator, which in turn produces electricity. Steam turbines are marvels of engineering, efficiently converting heat energy into mechanical power. The efficiency of any heat engine, including steam turbines, is governed by fundamental laws of thermodynamics. Sadi Carnot, a French physicist, established a theoretical limit on the efficiency of heat engines, known as Carnot's theorem. This theorem states that the maximum efficiency of a heat engine depends on the temperature difference between the heat source and the heat sink. In simpler terms, the hotter the source and the colder the sink, the more efficient the engine can be. Section 5. The Clausius-Rankine cycle. A symphony of energy transformation. Traditional power plants often employ the Clausius-Rankine cycle, a thermodynamic cycle that optimizes the conversion of heat to electricity using steam as the working fluid. This cycle involves a series of stages, including heating, expansion, condensation, and pumping. Each stage plays a crucial role in maximizing the efficiency of the power plant. The Clausius-Rankine cycle has been a cornerstone of power generation for over a century, providing a reliable and efficient means of electricity production. Section 6. The Organic Rankine cycle, harnessing low-grade heat. While the Clausius-Rankine cycle excels in high-temperature applications, the Organic Rankine cycle, or ORC, emerges as a suitable alternative for harnessing low-grade heat sources. The Clausius-Rankine cycle is widely used in traditional power plants, where high-temperature steam is generated to drive turbines. However, not all heat sources can reach such high temperatures, and this is where the ORC comes into play. Unlike the traditional cycle that relies on water, ORC utilizes organic fluids with lower boiling points. These organic fluids, such as refrigerants or hydrocarbons, can vaporize at much lower temperatures compared to water, making them ideal for low-grade heat recovery. This allows the ORC to operate efficiently even when the available heat source is not extremely hot. This characteristic makes ORC particularly well-suited for capturing waste heat from industrial processes, geothermal sources, and solar thermal systems where temperatures are typically lower. Industrial processes often generate significant amounts of waste heat that would otherwise be lost to the environment. By implementing ORC systems, this waste heat can be converted into useful electrical power, thereby improving the overall energy efficiency of the industrial facility. ORC systems offer a promising pathway to utilize otherwise wasted heat and enhance overall energy efficiency. In geothermal power plants, the naturally occurring heat from the earth can be harnessed more effectively using ORC technology. Similarly, solar thermal power plants can benefit from ORC by converting the collected solar energy into electricity even at lower temperatures. By integrating ORC systems, we can make significant strides in sustainable energy production and reduce our reliance on fossil fuels. Section 7. Towards a Type 1 civilization, a tapestry of innovation. As we aspire to become a Type 1 civilization, capable of harnessing the full energy potential of our planet, advancements in energy technology are paramount. Solar thermal power plants, for instance, hold immense promise. These plants utilize mirrors to concentrate sunlight, heating a fluid to extreme temperatures, which then drives a turbine. Geothermal energy, another abundant source, taps into the Earth's internal heat to generate electricity. Section 8. Waste not, want not, the power of heat recovery. In our quest for sustainable energy, we must also minimize waste. Industrial processes, for instance, often release significant amounts of heat into the environment. Waste heat recovery systems capture this heat and utilize it for various purposes, such as heating water or generating electricity. By implementing such systems, we can significantly reduce our reliance on primary energy sources and minimize our environmental impact. Waste heat recovery represents a crucial step towards a circular economy. Section 9. A sustainable future, efficiency, and innovation. The journey towards a Type 1 civilization hinges on our ability to harness energy efficiently and sustainably. This means not only tapping into renewable sources, but also optimizing how we use and distribute this energy. We must continue to innovate, developing new technologies and refining existing ones. Engineers and scientists around the world are tirelessly working on breakthroughs that could revolutionize our energy landscape. From advancements in solar thermal and geothermal energy, which harness the power of the sun and the Earth's heat respectively, to the realization of nuclear fusion power, the possibilities are vast. Nuclear fusion, in particular, holds the promise of providing nearly limitless energy with minimal environmental impact. By embracing efficiency as a core principle, we can reduce waste and make the most of the energy we generate. Smart grids and advanced power plants are already leading the way in this regard. And fostering a spirit of continuous innovation, we can pave the way for a brighter future. Startups and research teams are collaborating globally, sharing knowledge and resources to accelerate progress. The mastery of energy is within our grasp as we develop more sophisticated methods to monitor and manage our energy systems. And with it, the potential to shape a sustainable and prosperous future for generations to come. Imagine cities where every building is energy efficient, every vehicle is electric, and every community thrives on clean, renewable energy. This vision is not just a dream, but a tangible goal we can achieve through dedication and innovation.